Yeah. Good evening, everybody. Today we'll be looking at loops in C sharp, presentation by myself and Abimbola Olaide. Um, Loops in C sharp, an overview. As a QA, loops are an essential concept that we need to understand, because loops helps us to repeat block of codes multiple times in our programming and in our testing. It makes it more efficient and powerful, which makes us not to have the need to rewrite new codes for each execution. There are different kinds of loops in C sharp. They also play a crucial role in controlling the flow of execution of our codes, especially in our automation. Why do we use loops? Loops are vital because they help us in our programming when we're writing our automation codes. They enable us to perform repetitive tasks with ease, in the sense that we don't really have to rewrite our codes each time we want to execute them, especially if they have got to do a repetitive action. It also helps us to automate the process of our code in terms of the code execution. Like I said before, instead of us having to write the same code over and over again, we can just use loops to automate the process, and then the same block of codes is being repeated in our automation. This will help us save time and also make our code to look concise and maintainable. Loops also allows us to iterate over collections, process large amounts of data, and implement complex algorithms. In C sharp, we have three main kinds of loops. We have the for loops, the while loop, and the do while loop. Take time to explain this. In the for loops, the control of the flow statements allows you to repeatedly execute a block of codes in a specified number of times. This will mean that you will know the amount of times you want to run that particular block of code, and then you impute that in your loop. For the for loop, we have different types of statements in it. We have an initialization statement, a condition for the continuation of the loop, and then an increment or decrement, as the case may be. It depends on how you want to use it. This is like a flow diagram of how the for loop works. You can see it enters with the initialization statement, and it goes into the for loop condition. If it's true, the code is repeated, and when you update it by your increments, it keeps updated, keeps going through the loop, and then when it finalizes the number of increment that you have put for it to do, it exits the loop. This is a syntax of what a for loop syntax looks like. It's like I said earlier, it consists of an initialization, a condition, and an iteration. The iteration will mean the number of times you want it to run. And then for an example, you can see what we have here. The variable I is equal to 0. That is the initialization statement. And then I is less than 5. That's the condition. And then I plus plus, that's the variable plus plus. That will show you the number of times you want it to iterate. It adds like +1, +1, +1. And then in the curly braces, you have the code you want it to run. And for example, this code is console.writeLine, and what you want it to print is hello world. So an explanation of that, of the for loop, the code is written in C sharp, and the C sharp compiler uses a for loop to repeat the statements inside it 5 times. In each iteration, it prints the hello world to the console. That means in which loop, the output that comes out of that loop is a print of hello world to the console. The loop starts with I at 0. That's that's the variable, starts at 0, and it goes in increments of 1. That means it will go an iteration of 1 for 5 times. This is just like an output of what this code, the output of this code is what we are seeing on this slide. So it's going to print hello world the first, second, third, fourth, and fifth time. By the time it gets to 5, it exits the loop. Another type of loop in C# is the while loop. Now, this is good to note that in this while loop, the condition is always tested before the loop can run. It will mean that before the loop can run, the condition has to be true. While the loop in C# is a control flow system that repeatedly executes, the while loop in C# is a control flow system that repeatedly executes a block of code as long as the specified condition is true, which means that the loop will continue to run as far as the condition that you have put in it is true. And when the condition becomes false, it exits the loop. So this is an example of a flow of how it works. This is the loop, and as far as this condition is true, the loop will keep running. And when it becomes false, it exits. Okay? The code defines the variable. The code will define the variable. So this is the syntax of the while loop. The condition, you can see the condition is always coming first. So the condition is while the count is less than 5. For example, the initialization is at 0, and the console.writeLine counts plus count plus plus is the block of code. So if this condition is true, it's going to execute this block of code, and it will keep executing this block of code until count is more than 5. That's when it's going to exit. So like an explanation of that code, this code defines the variable count and initializes it to 0. That means it starts from 0. It then enters a loop that continues as long as count is less than 5. In each iteration, it prints the current value of counts and it increments it by 1. The loop will execute 5 times, displaying the values from 0 to 4, as you can see from the output here. So it's going to, this is the first one, the second one, the third one, the fourth one, and the fifth one, because it's executed 5 times. And the third kind of loop that we have is the do-while loop in C#. The do-while loop is keyword do and another keyword while. It means the do-while loop in C# is a control flow system that allows the block of code to be executed repeatedly based on the given condition. Now, in this kind of do-while loop, in this type, the code will be executed once, at least once, and then it checks to see if the condition is still true. And if the condition is still true, it's going to continue the process. It's going to continue executing the code. So it's going to keep executing the code before it checks. So when it checks and sees that the condition that you have given it is false, it exits the loop. As you can see here, this is the block of code. It's going to run this code and check that the condition is true. If the condition is true, it runs it again. If it's still true, it keeps running in the loop form. And then once the condition here is false, it exits. This is like a syntax of the do-while loop. You have the keyword do, and then you have the code to be executed in a curly braces. And then after the code, you now have the condition. So it always executes the code at least once to see if the condition is true. and the condition is true, it keeps executing the code. And once the condition becomes false, it exits the loop. Like for this example we have here, you can see the output on the next slide. This code uses the do while loop in C# to repeatedly print the hello world to the console. You can see that the hello world is printed 5 times because it goes through the loop total of 5 times. And immediately after the 5th time, the condition becomes false and then it exits the loop. Some basic examples of using loops in C#, we could use it for calculation of sum of numbers. Suppose we want to calculate the sum of all numbers from 1 to 100. We can use a loop, and in this case, it's a for loop that we're using to iterate over the numbers and accumulate the sum. And this is the code that we could use for that. The initialization code, then you can see the condition, and then you can see the block of code. The code calculates the sum of numbers from 1 to 100 using a loop. It initializes the variable sum to 0. That means it starts from 0 and then iterates through numbers 1 to 100, adding each number to the sum. So as it's going from 1 to 100, it's adding the sum of all the numbers together. Finally, displays the calculated sum using the console writeLine function. And there you see that the output will give the sum of all the numbers from 1 to 100 to be 5,050. At this state, I'll hand over the practical explanation to Abimbola. Thank you very much.
Right. Good evening, everyone. So, my name is Abimbola, and I'll be handling the practical section of the for loop. So please, can you share your screen? So we're going to do most of the question, then the rest is going to be like a take-home assignment. So for you to practice. So can you please share your C# code, or anyone that wants to share their code? So it's just for us to. So the reason for the practical is just for application. How can you apply it in your day-to-day life, or in case you have been interviewed, how can you approach interview question? Because some of us maybe applying for job and interview will be difficult. So this is just the fundamental they may ask in your interview. So can you can you please share your screen, your C# code, or anyone that wants to share their screen? Visual Studio, please. Thank you. Right. Okay. Thank you very much. So, right. So you can just delete all these ones. So you can just start again. Yeah. Thank you. So, those buttress what OM said so far. So generally, loops are just what we. It's just some lines of code that help us to do repetitive tasks, but they are the fundamental part of programming. Okay. With loops, we can achieve a lot. Loops is just for condition. Okay. Sorry, loops is mainly used with condition. That is if statements, switch statements, or as you know. So we're going to start. So the first question we're going to do is getting the sum of a number. Sorry, getting the even number, printing out the even number from 1 to 10. So we're going to use a loop for that. And we can achieve it using for loop, while loop, and do while loop. So I'll do the for loop and the while loop. Okay. Then you can do the do while loop as an assignment. So for the for loop, so OM kind of type for me, please. So for loop has 3 main parts. So the first part is going to be like where you define your variables. So you define your variable inside a bracket. So a variable is like a container. So that's where you store your temporary data. So it's like a container for your data that you want to use. So you, oh, can you open a circle bracket, please? So then we'll do VAR. So that VAR. So the VAR keyword is just like, how will I put it? It can hold any value. So it's more like an object. So it doesn't really have a specific type. So that is for the VAR keyword. Um, but if we want to be precise, you can delete the VAR and put int. Can you delete the VAR and you put int from place? So we're using int because int is for integers, right? So then you can put space. Then you can put I. So AI has almost completed everything for us. So you can put it, can type I. Right. So those two. So int I, right? So int I equals to 0, we're defining our variables. Okay. So int, so we can, like I said earlier, we can change the int to var, so which is var keyword. Then I less than 10 is the condition. So for every loop you are going to be writing, you will need a condition. If not, you're going to have an infinite loop. Okay, so we're going to see ways we can avoid infinite loop as we code along. Okay, so the next part of the statement is we're incrementing the I. So this is how for loop is. So anytime you see something like this, that is a for loop. Okay, so you first define your variable. So that is int I equals to 0. You do I less than 10, which is our condition. Then we increment I. If we don't increment I, we're going to be having a infinite loop. So now this is going to print. So can you run the code for me, please? Let's run it. So as you can see, we've got our number printed from 0 to 9. So in case we want to include 10, so can you close the window? Thank you very much. Can you close the window? So in case we want to include 10, so we'll go back to our condition which says I less than 10. So we can also do I less than or equals to 10. So if you put a equals to sign, then we're also going to be including 10 to it. So which is what we want to do. But in some scenario, we may just want to leave it to those 0 to 9. And mind you, we don't necessarily need to start with 0. We can also change from that int I equals to 0. We could change it to 1. We could change it to 2. Okay, so you can change it to 1. So if you run the code now, right, can you run please? So you'll see that it's going to start from 1 and we're going to be including 10. So as you can see, wow, that is from 1. So we just change part of the condition. So meaning our variable I is starting from 1, not 0 anymore. And the condition less than or equals to. So as long as I is less than, is it less than 10? No. But is it equals to 10? Yes. So it's going to include 10 to it. So can you close the window for me, please? Then, so, but the question says to get the even number, right? So can you delete what's online that online 3, please? So now to get the even number, so even number in mathematics is just a number that once you divide it by 2, you get is, let's say you get, once you divide it by 2, there's no remainder. But in C sharp, division is a little bit tricky, meaning that if you divide a int that is I by another int which is 2, you're going to get back a whole number due to the way they actually programmed it. So if you want to get an integer, that's double. So that's another topic for another time. But in order to achieve that, there's also a way we can get it, that if we divide by 2, if we divide I by 2, we can show the remainder. So like I said, there is no remainder if we are dividing by 2, but if there is a remainder, it means that it is a odd number. So, and there's a way for us to get the remainder, the division of a remainder, that is by using the modulo sign. So if we want to print out only the even number, the way we will achieve that is by using the modulo sign. So we're going to write a if statement. Like I said, for loop and if statement go side by side. So can you type if state and if, please? So if, open your bracket, the circle bracket. So now our condition is if I modulus 2 equals to 0. So the modulus is like the percentage sign. So that what is called modulus. So if I modulus 2 equals to 0, so you change the 10 to 2. Right. So this is a way for us to check our even number. So the modulus, once we do a variable modulus another number, that is to get the remainder. If we do the division, that is to get the actual number. Maybe we say 5 divided by 2 now, that is 2.5. So the modulus is going to be 5, and the whole number, if we divide the number, it's going to be 2. So something like that, yeah. So the modulus is just the remainder. So sorry, the modulus is the remainder. So we're going to, if we do 2 divided by 5, the remainder is 1, and the real value is 2. So can you open and close curly bracket, please? So when you are writing your condition, you write your condition in a circle bracket, right? But um for your closure, which is what we are going to write now, that is inside a curly bracket. So you just click on enter. Oh, please, Harold, go on. Harold, your answer up. Yeah.
Thank you very much, Abimbola. Please, I need you to do something for me. When
Right.
you go back to line 1, right?
Yes.
Please, can you explain the function of that int I equals to 1?
So
the I less than equals to 10 and I plus plus, because I can understand that those three are doing different functions, right?
all right then. Okay, so the first one is anytime you're defining a for loop, you need to have a variable that you are looking up to. Let's put it that way. So which variable do you want to work on? Let's put, so we're working on I, so we're going to declare I. So this I can be anything. You can call it name, you can call it age, you can be anything. So but it's just I that is common.
To understand it, so that's the initialization statement.
That is variable initialization. Okay.
What
So
about
the
the
first
what about
part
the I, the I loop that is less than equals to 10?
So that is the condition. So you need the condition. Okay.
Okay.
Why would this loop run? Because it is a loop. You need the condition to run.
Super.
Right.
Super. Then
So
the last
that is the condition. Then the next one is called an increment. Okay.
Super.
Because we don't want an infinite loop.
Correct.
So we'll talk about infinite loop later on.
Super. Thanks.
No worries. So in line 4, right? So you can just do you can just print it. You can do console.writeLine. Then you can print I. Well, I don't know if I said it before, but for loop or loop generally is in most programming language, if not all, because there are different paradigm in programming. There's functional programming, there is object-oriented programming. So, but generally, there's always for loop in all object-oriented programming language. That is Java, JavaScript, Swift, Kotlin, so etc. So now let's save it and let's run the code. So we should see 2 to 10. That should be printed 2, 4, 6, 8, 10. That should be printed out. So as you can see, so this is our even number printed out. So the question can also come in another form. They can tell us that okay, we should return an array or a list of the number, but we're not using a method, so we'll skip that for now. But you could do that as an assignment. So you could tell us that okay, write a function that contains all even numbers. So maybe you're given a range of value, maybe you're getting from a database, be it you're just creating like a loop, like what we are doing. So they can just tell you that oh, you should create a function that does that. But that, like I said, there are different methods of achieving the same thing. So one way is a for loop, another way may be a while loop, probably a do while loop can also achieve that. Another thing you can use is called LINQ. So LINQ is like a functional, it's just C# in a functional programming way. So it's just one line, and that LINQ is, if you know SQL and you know a little bit of functional programming, LINQ is going to be very, very easy for you to comprehend because it uses functional programming stuff. But this is not about LINQ. But like I said, we could use LINQ to achieve the same thing, and it's just like one or two lines, which is way cleaner than this. But it's not easy, it's not really readable. So we'll talk about comparing readability and speed as long as we do the interview question. So can you close this please? So this is just for us to print our even number, and if we want to print odd number, the only thing we just need to change is our condition. So that is I modulus 2. So if it doesn't equal to 0, then that's going to be an odd number. So to what is the not equals to in C# or in Java? So that is the negation sign, which is our exclamation mark. So OM on line 3, can you just change the first equals to, the first one, the equals to sign, delete it, then you put a exclamation mark, please. Then you run it. So we're going to be having a odd number because the exclamation mark is like a negation. So it read if I modulus 2 doesn't equal to 0, then you print I. So as you can see, so we have 1, 3, 5, 7, which are all odd numbers. So I hope that part is clear. Before we go into the more, so we're going to use a while loop to also achieve the same thing. So you understand, you see how it actually works before we go into the real question that we have. All right, can you close it? Thank you. So now, so we're going to be using a while loop to achieve the same thing now. So maybe create a line on line 7 thereabouts. So now a while loop is a little bit tricky. This is, a lot of people tend to have infinite loop when it comes to a while loop. And infinite loop can crash your system if you are not careful. So it can also crash the CI/CD pipeline. Though there are a lot of preventive measures that can that will prevent it from actually happening, but you don't want to waste your company CPU resources online because it is, the company is paying for the CPU resources on Azure or whatsoever cloud provider they are using for their pipeline, be it GitHub Actions or whatsoever. So you need to be careful. So you need try not to crash your computer, or try not to crash or make the company overspend their budget. So we need to be careful with while loop. So the first thing is, while loop is mainly used when we don't know the condition. For instance, if we want a user to enter their name, right, and maybe they are filling a form and they don't want to enter their name, but they keep pressing the submit button. So we could check that, oh, as long as this user has not entered our name, right, we can disable the submit button. As long as as long as we don't know, so for as you can see, our for loop, we know that I is less or equals to 10, right? We know our condition. But for while loop, we don't necessarily need to know the condition. So we could we're going to introduce a statement called break statement. Okay. All right. So while loop is just used when you don't really know the condition. If not, you are good to go with for loop. For loop is cleaner and very, very easy to wrap your head around. You know the condition. There is no way you can really have infinite loop, but it's also possible to have infinite loop. So before we go to the while loop, so OM, can you please change the I plus plus to I minus minus, please? Yeah, they run it. So but you're going to close it very quickly in a way. You can see what's going to happen. So the number is going to keep going because, see, as you can see, it's going to keep going. This is an infinite loop. So you can close it, so don't crash your system, but to keep going infinitely. Yeah, close it. That's it. So that's how infinite loop works. It's going to keep going. So why do we have an infinite loop over here? Because our condition changed. So sorry, the condition did not change, but our value that we're incrementing actually changed to decrement. So to decrement in C sharp, you use the double minus. To increment, you use the double plus. So so our condition still reads the same, which is I less than 10. So our loop is going to run as long as I is less than 10. But if we are decrementing after the loop, okay, that means the first iteration, our I is 1, I is less than 10, so 1 is less than 10. Then the next time we decrement it, our I is 0. Okay, is 0 less than 10? Okay, true. What are we going to do again? We're going to decrement I again. So that's going to keep going till we crashes the system. So the next loop we're going to be looking at is going to be while loop. So I hope that makes sense. So a while loop. So you can just a while loop start with while. So you can leave it as while true. Yeah. Just click on tab. So as you can see, here I already put that this is going to run forever, which is true. It's going to run forever, which is not what you want. So like I said, while loop is something that can run forever if you're not careful. But with while loop, you see for loop now, our int I is inside the for block, meaning that we can't access it. So it's more like a private property. Though it can be accessed within the block, but it can't be accessed outside of the for loop block. So meaning that our I variable does not exist, meaning we can also reuse it. However, for the while loop, there is no block to accommodate our variable initialization, which is that int I equals to 1. So for while loop, we need to declare our int I equals to 1 outside of the loop. Okay. So if we're going to be using this, we need to declare our variables outside of the loop, then before we do our condition. So on line 6, please. So you can just create a new line between line 6 and line 7. So you can just put int I equals to 1. Or you can leave it as count equals to 1. Then put a semicolon. Yeah, that's it. So in line 8, where we have true, so our condition is true. So our condition is a boolean. So what I mean by boolean is either true or false. So if it's false, this is not going to run. If it is true, it is going to run. So now our condition is going to remain the same, which is I less than or equals to 10. So you're going to put I less than or equals to 10 in the, no, not there, no. You're going to put it inside our brackets, the true, where we have true. You delete true, then you put I less than or equals to 10. So which is a condition. So you can't just put any statement there. The statement you need to put inside the bracket must be a condition. I less than or equals to 10. Then, so this is going to run forever. Why? We've not incremented our I. So if we were to run it now, we've not incremented our I. So, I don't know why that is red, but it shouldn't be red anyway. But we've not incremented our I, so our I is going to be 1. And 1 is going to be less than 10. So let's run the loop anyway. Let's run it. So let's see. So this is going to be an infinite loop.
Should I comment out the for loop?
Yeah, you can comment it out. That's fine. 496. Yeah. So you can run it. Gonna have infinite loop now. So our I is going to be 1. This is going to run forever. Forever. So you can close it. So that is an infinite loop. So the reason why we have an infinite loop was because we did not increment our I. So unlike the for loop where our I is being incremented inside the for block, here our I is not being incremented, and the while loop doesn't really have a way to tell us that, oh, our I is not being incremented. So to get around infinite loop, one way is to use a break statement. Okay, so we could use a break statement to actually stop the loop. So it's going to exit out of the loop, or we could also use a return, but it's better you use a break statement. So let's increment our I. So you increment your I at as the last result, which is going to be below the console.write line. So but just inside the block. So you do just that is on line 11, but inside the block of code, inside the curly bracket. Or you can just create a new line between line 10 and line 11.
And 10 and 11.
Yes, create a new line between line 10 and 11. Then you do I plus plus. Then you run it again. You see there is not going to be an infinite loop. So as you can see, this does run for, let's say, 10 times. 1 to 10. So this run for 10 times. So you can close it. So we've gotten similar result with our for loop. But as you can see, there are a lot of lines of code. We need to declare our variable outside. We need to define our loop, our while loop, and we also need to like increment downward. When in our for loop, we could just do it once. Like I said, anytime you have a choice between a for loop and a while loop, always pick a for loop, unless you don't know the condition. But for loop and while loop can achieve the same thing. So they're just loop. So while loop is just mainly used when you don't have any, when you don't know the condition before end. So that is why you can do while true. Then once you met the condition, then you can break out of the statement, out of the loop. So you're going to delete line 10. So we're going to do the same thing as we did in line 3. So we're going to print out the even number. So if
Should I delete line 11?
no, don't delete line 11. If not, to have an infinite loop.
Okay.
So you do if I modulus 2 is equals to 0, double equals to 0. So double equals to 0.
Modulus double.
No, delete it, please. In the negation sign, this exclamation mark, exclamation, you delete the exclamation mark, then you put a equals to, for equality check. So you run it, then this should print out the even number. Between 1 to 10. So you can say 2, 4, 6, 8, 10. Okay, so you can close it. So that is for while loop and that is for loop. I hope it's clear before we move on to the more advanced ones. Yeah, please go on, hear me.
Sorry, I want to take you back to the for loop. When you the increment the 1 plus plus, you change it to 1. Sorry, I plus plus change it to I minus minus. When you run it, it was infinite. It was going, not to stop. Is there any code for us to put for it to stop it?
Yes, we can put a break statement.
Okay.
So Owen, can you comment out the while loop and let's go back to the for loop from line 7 to yeah. So you comment back. So from line 8, you do from line 8. Sorry, from line 6 I meant. 8, 6. So you change the minus minus to, sorry, to change plus plus to minus minus. Then you change the 1. Let's just do 5 this time around. Let's start from 5. So now, so we have a statement to print out it. So we could also do another condition to check if our variable I is less than 0, then let us break, or if it is less than, if it is less than 1, let us break. So to do that, we can do that before we even print anything. That should be the first check we do in order to break out of the loop. So on line 2, can you create a new line, please? It's line 2 and 3. So you do if, so if I is less than, open close brackets, if I is open and open bracket, if I is less than 1, close your brackets. As you can see, just close the brackets, delete the 10, then put 1 to break. So this is going to stop us from having an infinite loop. So you may be asking, what other use case do we have in negative sign? There may be some time where we want to reverse our number. Maybe we want to go from 10. Like I said, our I can start from any value and our condition can be from any value. So we can go from 10 to 0. Maybe we want to print a number in reverse. So that is one reason why you can, that's why you have the minus minus inside the for loop. So can you run it, please? So we'll have it in backward way. And see, just the odd number got printed out, but we break out of the loop. So if the break statement wasn't there, we're going to be having an infinite loop. I hope I answered your question.
Yes, thanks.
Yeah, Gabriel, please go on. Gabriel, your hands are up. Gabriel, please, your hands are up. Or should we proceed? Okay. Yes. So let's continue. So we're going to start with the interview question. So that's going to be the playwright And like I said, what I'm going to do here is also applicable to any programming language, and not necessarily in programming language. Some part are actually a platform specific code or language specific code, but and it works across framework. So this for loop initially is almost everywhere. So the same code you put is also what I'm going to put in Java, and it's going to work as expected. Only the console.write line that's going to change a little bit, which is going to be like system dot something something dot out, blah blah blah, system dot in dot out, thereabout. So can you go back to the slide, please? Let us waste my time. Right, so we want to do question one, which is going to be validate all link on the page. So I'm going to explain the concept to you, and I hope you get it once. So now, to validate all link on a page, so I'll just take us a little bit back to HTML and CSS. So in HTML, the only place we are allowed to put a link is a tag. So that's one way you could get it. The only way we are allowed to put a link in a browser or in a web page is by using the a tag. Any other tag cannot put a link unless they use a different element. But generally, link, if you are writing a semantic HTML, which is mean like a clean code, the way we have it in text. So if you are going to be writing a semantic HTML, generally developers use a tag for their link. So one way we could achieve that is by selecting all the a tag in the browser, which is very, very easy to achieve in. But that is not the validation of the link. So that is just step one. So this first step is for us to select all the a tag in the link in the web page or the browser. Another way for us to select all the link is we can in this in HTML also for the a tag, only a tag that has this attribute is called href. So the href is what contains or what holds the link. So if you're going to be putting a link, the href is what's going to be holding the link. So we could also select the href. So we could in Playwright, we could select by attributes. We could also select by tag. So that is one way we could get all the links. Okay, so the first step is to get all the links. The next step, after we've gotten all the links, right, we're going to loop over all the links. You may ask why, because we need all the links. So first step, we get all the links that is available on the web page. The next step is for us to loop over all the links. Then the third step is just for us to check if the links are valid. So, and this is going to be a very platform specific or language specific code that we're going to be writing. But the first and the second step is what really, really matters. So, like I said, loop over, and the next one is just some. So let's go back to and similarly, if you are using Selenium with, you can do the same thing with you just okay. I'll just explain how you do it. So let's go back to Visual Studio, please. So I'll just show you how you do it in Selenium. So have you installed Playwright in this project?
On this very project, no.
Yes.
No, on this project. But on
Let
another
us install
project.
Playwright then. Or if you have the one with Playwright, we could use that one then. We
Okay.
don't need a feature file, we just need like something that will just explain the real concept, because most of the time this exercise will just ask you that, oh, can you do this? If not, it's going to be in your page object, which doesn't really need a feature file.
Okay, so let me just go to the one that already has.
So So can you just create a new C# class just for us? Thank you. I'm at the root of the project. So you can just give it any name.
System is a bit slow. I don't know why.
All right. So we have namespace, we have internal class loops, which is probably fine. So now, so in line 10, we're gonna write a method. Okay. So since we'll be using Playwright, then we're gonna be using asynchronous process. So now click on enter. So you do public, you write public, small letter P, public. So public allow our method to be accessible outside. So then you do space, okay, async keyword. So then you space tags. So the tags means it's not returning anything. Tags space. So we could write validate all links, capital letter V, validate all links, capital
You got
letter
that?
A, next all, then capital letter L, links, open and close bracket. So as you can see, even A has already given the answer already. So you can just click on tab anyway. So this is what I said initially, which is the first step is just to get all our links, which is we could use the A tag. So we're getting the locator called A tag using the A tag, like I said earlier, right? We could also select by the href. So we will select by the href. Then the next step is for us to loop over the links. So because we need to process each of the link separately, they are not the same. So that is why we are looping over this link. So the next step is we're trying to get the attributes from the link. So like I said, the href is what stores the link. Then so we're trying to extract the attribute. So in Playwright, if you want to extract the attribute, you do link or maybe the variable name dot get attributes async. Then you pass in the attribute. So if you want to get name of the link, you pass in rather than href on line 17, you pass in name. Okay. So now the third step is just for us to check. So if href is not equal to null, so we're checking if the href is not null or empty. So because if it's null or empty, then it's not a valid link. So you could dismiss that. So next one is an href start with HTTP. So HTTP is not secure, so I would rather we go with HTTPS rather than HTTP because a lot of people use HTTPS. So the only people that use HTTP is people that are developing locally. So you could change that to HTTPS. Okay, so that's more secure too, in case you are going to run the code. Then this try catch. So I'll just explain what try catch is. So try catch is a way for handling an exception. So exception is anything that can break our programming flow. So it can be due to user error, database error, any sort of error that we did not catch ourselves. So that is important. The keyword we did not catch ourselves. So in Selenium, unlike Playwright, though Playwright has its own exception, but it's very very common if you work with Selenium that iWeb you see a lot of selector this something exception this exception. So I think Playwright have just like 17 worth of exception if I'm not wrong. but more than 10 anyway. So, and there are different ways you can handle those exceptions. But generally, if you are going to be handling exception, you want to do it in a try catch. So the try is where you perform what you want to perform. Then the catch is what you do after. So maybe it's the worst come to the worst, you have an exception. So your catch block is where you do after. Okay, do you know what? I just want to print to the user that unable to log in. I just want to print that database error. I just want to tell my developer it is maybe the database has some sort of bug in the database design. So that is what your catch is meant for. So the try is for where you do your main action. The catch is just for where you do your maybe exception handling. So the exception handling actually works in catch, and try and catch is also in most programming language, if not all. Only few doesn't have it, and it is in most OOP languages, which that is Java, C Sharp, JavaScript, Swift, yes, and Kotlin. There's try and catch this, and the way they work is always the same thing, right? With only few modifications. So the next line read VAR response equals to await page or request or get async href. So this is just a way for Playwright to send a request to the href. So Playwright is also used for API testing. So this is one of the powerful ability of Playwright, unlike Selenium, where you have to use something like the system like, but with Playwright you could have something like this and it's going to work properly. So you could use Playwright to send a request and you could get the response back. So, and in line 23, it's just saying if response is not okay. So that's a negation sign. So response dot okay is when it's successful. Then response dot not okay is not successful. Then then the next one is okay. This is to print the broken keyword. Then the exception, if there's an error accessing the link, maybe there's a 404 error on the page, maybe that's when you're going to catch your exceptions of that step. So it's just online 23 is just Playwright. That's a Playwright specific method. There's nothing special about that. So I think if you go to Playwright documentation, you will see it. So that is does it. So the first step is just for you to loop over all the links. The first step is to get all your links. Next step, loop over your links. Third step is just for each link, you're going to try to get the attribute. You check if the attribute is not null and if the attribute probably start with HTTPS. So the other condition is not compulsory, but it is good to have, because if you are going to be in an interview settings, you're going to be competing with a lot of people. So knowing why you put it, and if they ask is it compulsory, it's not really compulsory, but it's just to be on the safer end, so you don't end up accessing links that have been asked. So because if you are accessing a HTTP request, it means that maybe you don't know too much about security. So that's why I changed it to HTTPS. Then online 28 is just our try, which, like I said, is for exception handling. Then on line 22, it is for the response, and that is Playwright specific method. And line 23 is just to check if our response is okay or not, and we print it out. So it can come in another variation and can say, what should happen? I want you to return all valid links. So if we want to return all valid link, one way we could do it is, we're going to be returning all valid link anyway. So on line 11, so we're going to modify the method a little bit. So rather than return just a empty tags on line 11, the tags, so you do a square bracket, a angle bracket, open and close angle bracket. So the angle bracket in C# is called a generic. So basically, a generic is more like it's like an object that can store anything, similar to the VAR keyword, but this time around we can even make our generic is even more it can make it more specific, or it can contain anything. So if we're going to be returning a string, maybe the name of the link that is broken, then we could put it in a string. Inside that angle bracket, we could put a string there. And if we're going to be returning a list of maybe a list of string, which is the link that have been broken, then we can put the link there. So can you put list of string, please? So the L is capital letter L, list of string, yeah. The L is capital letter L. Then the list is also a generic, not list of. The list is also a generic. Open now, like you see the angle bracket again. So the list is also generic, meaning the list can contain any variable type, be it an object, be it a non-primitive type, which is our integer or string. Sorry, integer or boolean. So string is a primitive string is a non-primitive type, while integer, char, they are primitive type. So you can do a angle bracket similar to what you did for the tags.
In front?
Yeah, inside the tags you do open up in angle brackets.
Oh.
Inside the tag. So you see, inside beside
Sorry, 1 minute. I'm not hearing questions. People asking that what is primitive type, what is non-primitive type. I should be, I think people should be asking those questions, unless I don't want to guess or assume that everybody knows what that is. All these jargons, I think if they are not clear, it's good to kind of ask questions as well. And Ola, if it's also as you are saying the jargons, it will also be good as a tutor, right? To be kind of explaining them little by little as well. Anyway, so and yeah, if I may, why is string not anyway? Because most people use string, right? So we know that it's not. So what is between classification of a string and an integer? Anyway, yeah.
So let me just say primitive type and non-primitive type is a primitive type is actually stored, is copied by value, and a non-primitive type is by reference. So what I mean by value and so a value means, for instance, now if we declare a int I equals to 1 and int x equals to 2, or int x equals to I, it is copied, meaning that it is, so that means our I is also, sorry, let me put this way, sorry. Let me just share my screen. You can just stop sharing, please. Let me just share my screen. So to make, I'm using Java anyway. So to make a lot more, makes
Expand it a bit. To...
Is it better now?
Yes.
All right, so I'll just switch here. But this is Java anyway, but it's applicable to C#. So now, what I mean by primitive type is, for instance, if I declare a variable, so now I declared a variable called I and I put it, and then just change it to 2. So and then just put it as 9. So I set it as 9. Then I put the variable of I store it in variable X. So if I am to print these two value now, so in C#, you have something like this. you have something like this in C sharp. Maybe you have something like this in C sharp. You have something like this, but this remain the same. So ignore this one for the meantime. This is a new Java feature. Anyway, so you would have something like this in C sharp. So what if I run this command line now? So what you have is going to be 99. So meaning I just put the value of I here, of I inside our X. But since it's the non-primitive type, sorry, since it's a primitive type anyway. So if I update my X, so if I update my I, so what you're going to see is I have 2 and I have 9. No, now supposing it was a primitive type, sorry, supposing it was a reference type, this is going to be updated. This our X is going to be updated because it is stored by reference. Now let me create a new object. Let me just create a new class. Sorry. So, so this is just a constructor to set it, a setter and getter method. So this is those ignore this for the meantime, but this is a object, or this is a class anyway. So a class also, this is a class, so this is a reference type. So what by reference type is that, so I'm going to create a new and to string. A reference type. So I'll do I can pass in
Okay, I think you are going off point, right? So I don't think it should be to this level, right? It's just to So
you just to show them what I mean by
I'm not
primitive
sure
type.
you've not lost some of people that right? So computer 101 quickly, I would say, right? A string is technically a class, right? So it's not the standard string. It's not a standard identifier or data type. So like integer, Boolean, float. That's where they start with lowercase, actually, right? So and string start with capital S, right? Because in itself, it's a derived data type. So, and that's what we are taught in Computer 101.
So so Let me just run the code and I'll explain to you. Sorry, I didn't set it. So I'm going to set it. I'm going to explain it to you now. So this is initialization of my name, and I'm just setting this user to my name, similar to what I am doing over here. But I am replacing this one with Peter. So I'm trying to print out Peter. I don't know what I'm doing wrong. But generally, what you are meant to get is you're going to ask something like this. I don't know what I'm doing. Bear with me. But what I'm meant to get is this is also going to change to Ola, because they are being stored by reference. Let's see what I'm doing wrong.
You stored Ola into John, right?
Yes.
So
I'm meant to get Peter I'm meant to get Peter also here. Am I doing wrong?
okay, hold on. So you printed Ola and then you asked it to also print John, but John is got Ola stored into it. And at the top right, because what is it printing for John? It's printing Ola, right?
Oh. Yeah, it's printing Ola.
Yeah,
because in the first instance.
Yeah.
But this next instance is meant to also print John, it's meant to print Peter this time around now. Or is it printing Ola?
Because you've not, I think because John is still got Ola, it's not, I don't think it's changing initialization, the assignment anyway.
Let's see. Bear with me. But I just wanted to show you, like, I don't know if you are looking at this thing, but look at the memory reference. They are the same thing.
Okay.
So this is just like, it's more of a memory referencing, because I don't know, maybe they've updated Java, but this is, as you can see, the memory reference. They are the same thing. Let me see. And let me see if that's the memory reference.
Yeah, that's different, right?
See.
Yeah, but I think we need to go back to So I'll quickly kind of write off anyway. So how Dr. AAB, I don't even know his name, taught us about this anyway. So which I know is quite I don't know that it's simpler anyway. So because we have derived and standard variable, which is called primitive and not primitive variable or data sets, right? So all those ones that start with lower cases, right? Like integer, float, boolean, and everything. They are primitive one actually, which is what in the language you call the standard data types. And string is not, right? That is the reason that you see string and you don't write it in lowercase, you write it in uppercase. because it's actually derived, actually. And I was also made to understand that string in itself is like a class on its own, right? So you are not actually using it as you use an integer technically, right? So that is one thing I think, to just make it simple, right? So if that's okay.
Yeah, something like that. But as you can see, we have the same memory references. But if I'm to print out, I've forgotten how to print out the memory reference of I and X. They'll be different. Let me see if I can print it out. What not to print out the memory reference of I and X. But I'll look into this anyway. I'll come and tell you why it's not working. But I'm meant to have the same because they are pointing to the same memory. So if I update, let's say it was John I updated, I should have the same thing. Like it should be true. So I don't know. It's creating a new memory reference for it. Anyway, so I'll look into it and I'll come back and tell you. So let us go back to the loops. But as you can see here, we have same memory reference. So, but if I'm to print out the memory reference of this one, we're going to have something different from each other. Stop sharing my screen. So, you can continue sharing your screen. Just round up. Please, can you share your screen? So just to round this one up, so you may be asked to return a list of you can be asked to return a list of links, so of valid links or invalid links, depending on how the question goes. So because they may ask you one question, they may also ask you a follow-up. So to return a list in C#, so in an asynchronous, so you put it in a task. So your list, after the T of the list, you're going to put a angle bracket again.
To close it.
Open the angle bracket. You open the angle bracket and you also close it. You also close it. Then you put in string.
Capital letters.
A small letter string. Java make use of capital letter for string.
Okay.
Yeah. So the main reason why it's red is because you're not returning anything.
Okay.
So now, so we're going to declare a variable, so which is going to be on line 12. We're going to create a new list of string. So to create a new list of string, you create a new line between line 12 and 13. So you're going to do list of, that's list you're meant to put the string inside the list colon on line 11. Look at, there's a angle bracket. You're meant to put string inside the one very close to the list.
Here.
Where your cursor is currently on.
Yeah.
Yes, you put the string there.
Okay, so I remove it from here, right?
Yeah, you remove from there, yes.
Here, right?
Yes. So as you can see, there is no more red anymore. So to declare a new variable on line 13.
Yes.
So that's going to be list of string.
Capital letter L.
Yes, please. So you could also, you could leave it like this, broken links. So that is, so now this is to get our broken link. So on line 26, so you could delete what you currently have on line 26. So we're going to add the broken links there. Okay.
Delete this.
Yes, the old line on line 26. So add the broken line. We're going to do href. Sorry, say href. We're going to do broken links. Broken links dot add href. That's just it. So we're adding the broken link. So like I said, the links is going to be in a string form. The one we're adding to broken links. Then in the ending of the method, we're going to return the broken links. So the ending of the method is, I think, is on line 34, 35. 34. Create a new line between 34 and 35. So it will just return broken links. So that's how you solve something like that. That's it, it's no more red anymore. And if you still red, to remove the red error in on line 11, in the circle, in the brackets, the circle brackets, pass I page. Type I,
Inside
capital letter I, capital letter I page, capital letter P,
capital letter P. Okay, sorry.
IPAG, yeah, I page space page. So you will replace our underscore page to page. Then that's all. That's how you resolve it.
There's
Then
another one here.
yeah, you also
The request is now read.
maybe the request does not really exist. Maybe it's just AI hallucinating. Put request there. Put
Where?
your
Okay.
let me see your screen properly. Page when a page issues a request. The request. Sorry, bear with me. Can you hear me?
Yes, I can hear you.
Right. So rather than using page dot request, we could also do something called page dot response.
Here.
Yes, page dot response. Plus or plus equals to. Or we could also do something like this. Page dot request filter. I'm going to send the code. So I'm going to send to the chat.
Okay.
I've sent it to the group. I've sent it to the chat, the Zoom chat.
What do I replace it with?
So you replace it with what you currently have.
On which
The
line?
response here.
On the response.
Yes, you delete what you currently have on line 23.
24.
23.
There's nothing on line 23. 23 is free.
Sorry, 25 minutes.
24.
Yes.
The response
So
on
you
line.
delete we'll delete our response.
Delete the response.
So we'll just we'll replace line 32 in line 26.
Line 30.
Yes.
I should replace line 32.
You move line 32, line 26, I mean, sorry.
Line 32. Line
Line
32.
30, you're moving what you currently have on line 30. You're moving to line 26.
Oh, okay.
Yeah. Just paste it there. Then you delete line 28. You delete the if statement. I think you have something like this.
Is it okay?
Yeah. You delete the curly bracket also. So you're going to do something like this, maybe something like this, yeah. So 29 to 31.
Yeah. Done.
Yeah, that's fine then. I think so. Something like this should work. Maybe something like this, yeah. Should work. Hopefully. But the whole logic here is just to like have something to just click on the link and check if, and it differs from platform to platform. Let me see. Let's see. So another way we can achieve the same thing is by using page dot run and await for request finish async. So we could also use that one too. So there are multiple ways of achieving the same thing. That's all I'll say. So this is just one way of doing it. So there are multiple ways of achieving it in Playwright. But I'm not confident about the page dot request field. I saw it on Playwright's website anyway. But I doubt it's going to work because I'm not even using our href over here. But this is what is on Playwright's website. So yeah, you can stop sharing your screen now. Share my screen.
Okay.
So I'll just show them what is on Playwright's website. So we have something like this on Playwright's website. Hope you can see my screen. So this is what like login of field request. So because our request is going to fail only if our link is not valid. So this is it. So like I said, there are other ways you can also achieve it. So maybe you read the documentation. So you could also try to, there's other stuff you can also. So if you can't go to this website, maybe it returns a failure, then your request is going to have some. So pass it. Connection starts. Connect your section starts. So -1 if not available. So you can use this one to also check. So like I said, there are different ways to achieve this request and response finish. So this is it. So this is from their website anyway. So but I'm not really 100% sure of, maybe that's how I did it. But this is what we're currently using right now.
Okay.
Something like this. Request dot failure. Awesome. So we could just add the request dots. But the request of failure returns a message based on what I understand, based on what it is doing. It returns a message why it failed. So stop sharing my screen. So that's just it. So we won't be able to do it. We won't be able to finish the main one. We've passed our time already. But we can continue next time. Right. Do we have any other question?